So in this video lecture we will be calculating the electric field due to a disk. So let's consider a disk of radius r like this. This is a disk of radius r, and there is a point P. There is a point P. We have to calculate electric field due to the disk at this point P. चार्ज डेंसिटी जो है इस डिस्क की वो दी हुई है आपको सिग्मा कूलम पर मीटर स्क्वायर. नाउ वी आर रिक्वायर्ड टू फाइंड इलेक्ट्रिक फील्ड एट दिस पॉइंट पी. तो इस डिस्क के केस में हमें एक एलिमेंटल रिंग की एक्सिस पर इलेक्ट्रिक फील्ड पता है. रिंग की एक्सिस पर इलेक्ट्रिक फील्ड हमने देखा है पिछले लेक्चर में भी, के क्यू एक्स अपॉन एक्स स्क्वायर प्लस आर स्क्वायर टू द पावर 3/2 होता है. तो यदि इस डिस्क को क्रिएट करना हो तो वी कैन क्रिएट दिस डिस्क विद द हेल्प ऑफ वेरियस रिंग्स, राइट. सो मान लीजिए ये डिस्क है अपनी, ये डिस्क है. इस डिस्क में हम क्या करने वाले हैं, एक रिंग कंसीडर करेंगे एक्स रेडियस पर. इस तरीके से एक्स रेडियस पर एक रिंग कंसीडर करेंगे हम, और इस रिंग की थिकनेस भी कुछ कंसीडर कर लेंगे dx टाइप से. सो हम ये एक रिंग कंसीडर करेंगे इस तरीके से. इस रिंग का चार्ज कैलकुलेट करेंगे. सिग्मा दिया हुआ है हमको. इस रिंग का एरिया निकाल के रिंग के एरिया को यदि हम सिग्मा से मल्टीप्लाई करेंगे देन विल गेट द चार्ज ऑफ दिस एलिमेंटल रिंग. और इस एलिमेंटल रिंग की वजह से इसकी एक्सिस पर हम इलेक्ट्रिक फील्ड पता करने की कोशिश करेंगे. तो यहाँ से x, या लेट्स से x दूरी पर, तो इस पॉइंट को ले लेते हैं हम. दिस डिस्टेंस इज x. तो यहाँ पर एक y रेडियस की एलिमेंटल dy थिकनेस की हमने रिंग कंसीडर कर ली, राइट. सो दिस इज y एंड दिस थिकनेस इज सिंपली dy. द स्मॉल एरिया ऑफ दिस ring will be 2 pi by dy, and the charge, small charge of this ring will be 2 pi by dy into sigma. So this way we can easily calculate the charge of this elemental ring. Now due to this elemental ring we have to find electric field at this point P. So small electric field due to this small charge dq will be k 2 pi y dy into sigma by x square plus radius square, which is simply y square to the power 3/2, and just we have to integrate it to find the net electric field at this point P. As limit we'll put 0 to r. Now here we can see that k, 2 pi, sigma are all constants. Y dy upon x square plus y square to the power 3/2 needs to be integrated from 0 to r. So for integration we'll use integration by substitution. We'll put t to be equal to x square plus y square, dt by dy will be 2y, dt is equal to 2y dy. So this so we can put in place of 2y dy just dt. So this 2y dy, I'm replacing all this with dt. So what I get here is k pi sigma upon 2y dy is replaced by simply dt, and this x square plus y square is simply t, so it becomes t to the power 3/2 and integration. Now k pi sigma integration of t to the power 3/2 will be t to the power minus 3/2 plus 1 upon minus 3/2 plus 1, like this. So this becomes k pi sigma, it becomes minus half, so minus 2 I get here, and 1 by root t I get here. I should again replace the value of t, which was x square plus y square. So minus 2k pi sigma 1 upon x square plus y square in under root with limits 0 to r on y. These are the limits for y, not for x, right? So minus 2k pi sigma 1 upon r square plus x square under root minus 1 by, if I put y to be 0, then what I get is here is just x. Adjusting this minus sign inside, I get 2k pi sigma. One x is also there. I just missed that x. K q x upon x square plus y square to the power 3 by 2. So this x is also there, which is also running in each step. I missed that, unfortunately. So x is there with all the terms. So 1 by r square plus x square under root minus 1 by x. If I put this x inside and adjust this minus sign, then what I'll get is 2k pi sigma 1 minus x upon x square plus r square under root. Now if I put the value of k as 1 upon 4 pi epsilon naught, then this pi will get cancelled, 2 with will be getting cancelled with that 4. So what I get here is sigma by 2 epsilon naught 1 minus x upon x square plus r square under root. So this is the electric field due to disk at point P, which is on the axis of the disk, Now let me consider a couple of special cases for the same. Some special cases. Case 1, if I have to find electric field at center of disk. If I have to find electric field at the center of the disk. In this case, I found the electric field at this point P, which is on the axis at a distance x. But यदि हमें electric field पता करना हो इस P dash point पर या center of the disk पर, तो what we'll do is we'll simply put x to be equal to 0 in above result. In that case, E at center will be sigma by 2 epsilon naught 1 minus 0 upon 0 square plus r square. This term will also become 0. So what I get here is sigma by 2 epsilon naught is the electric field very near to the disk, or almost at the center of the disk, right? So in case 2, what I do is, if I take the radius r of the disk to be very large, that is tending to infinite. If the radius due to this disk, radius of this disk is very large, then if I see the result, then in this case, if I put this r to be infinite, then this term, this result will almost tend to be equal to 0. If this result is 0, then I can say that electric field due to very large, or let's say infinite disk, very large or infinite disk, is equal to simply sigma by 2 epsilon naught. So sigma by 2 epsilon naught is the electric field due to a disk which is of infinite in size, or you can say this is the electric field due to a infinite plate, right? Infinite non-conducting plate. Due to the infinite non-conducting plate, the electric field is sigma by 2 epsilon naught, and it is independent of distance of point P on axis of disk. Point P can be anywhere, but it needs to be closer to the disk, right? Even at this point, or at this point, at this point, at this point, at all these points, the electric field will be same. That will be sigma by 2 epsilon naught. Okay.